My video presentation is regarding deep beams. First of all, what is a deep beam? A deep beam is a structural member whose span to the ratio is relatively small, and in this, shear failure is dominant, as we can see from the figure. Here in this deep beam, a UTL is provided, and shear failure occurs at the bottom in the arch section, and in this we see a two-point load applied along the length of the at the length 2-point loads applied in this deep beam, and we can see the failure occurring in this area. And we can see the difference between the UTL and the 2-point loads. These beams have been designed taking into account the nonlinear distribution along the depth and lateral bulking. It should be noted that the beams are sensitive to loading at the boundaries, and the length of bearing may affect the stress distribution in the vicinity of the support. Similarly, stiffening ribs, cross walls, or extended columns as support will be influenced by the stress distribution. The active height of the beam is limited to a depth equal to the span. A part of the beam above this height is merely taken as a load-bearing wall between the support. These rules are provided for both simply supported beam and continuous beam. It should be also noted that in the beams the requirement of force and flexural reinforcement is not large, and it is also important to detail the reinforcement property, as the beam's behavior is different from that of a normal sized beams. And the details of the reinforcement is given below. And here we see the reinforcement along the length of the beam, and this is the cross section of the beam. As you can see, reinforcements are provided along the whole length of the beam. Coming to the reinforcement, positive reinforcement. In a simply supported beam, due to the arching action, the tensile steel acts as a tie connecting the concrete compression strut. Cracking will occur at 1/3 to 1/2 of the ultimate load. Flexural stress at the bottom is constant for much of the span. The tensile reinforcement is for a positive moment and should be placed within the tension zone of depth equal to 0.25 times depth to 0.05 times length from the extreme tension fiber at the midspan. From this figure, we see the distribution of the positive reinforcement. We see the positive reinforcement placed at the bottom of the span or at the bottom of the beam. Here we see the positive reinforcement, and this is the cross section. Here we see vertical and horizontal reinforcement placed along the length of the beam, and here at the bottom we see the positive reinforcement provided at the tension zone. And next is the negative reinforcement. In case of continuous deep beams, not only positive but also negative reinforcements are provided, and this negative reinforcement should satisfy the following requirements. Termination of reinforcement. Negative reinforcement can be curtailed only in deep beams with length by the ratio more than 1.0. Not more than 50% of the reinforcement may be terminated at a distance of 0.5 times depth from the face of the support, and the remaining should be extended over the full span. We will see this in the next figure. This distribution. The distribution of reinforcement. When the length by the ratio is less than 1.0, the negative reinforcement should be evenly distributed over the depth of 0.8 times depth measured from the top of the fiber. Here we see the distribution of the negative reinforcement. Here on top we see the main negative reinforcement placed along the full length of the span, and in the middle zone we see the distributed negative reinforcement. As mentioned before, these are the evenly distributed negative reinforcement placed at a distance of 0.8 times depth measured from the top of the tension fiber. Coming to the vertical reinforcement, the load applied at the bottom of the beam induces hanging action. This is due to the self-weight of the deep beam. Hence, the suspension syrup should be provided to carry the concentrated load. Vertical reinforcement is more effective for member strength than horizontal shear reinforcement in deep beams. However, equal minimum reinforcement in both directions is specified by the ACI code to control the growth and width of the diagonal cracks developed. Side reinforcement. According to IS 456, the side face reinforcement should be provided as per the minimum requirement of walls. For deep beams of thickness more than 200 millimeter, the vertical and horizontal reinforcement should be provided in two grids, one near each face of the beam. The horizontal and vertical steel placed on both faces of the beam serve not only as a shrinkage and temperature reinforcement but also as a shear reinforcement. In the previous cases, we see the vertical and horizontal reinforcement here. These are the horizontal and vertical reinforcement placed along the full length of the